Hello everybody. Today we're going to talk about the slope of a line and how to find it. So what we're going to be able to do is find the slope of a line given either a graph, which is, not too bad, pretty easy. You might have done it in the past already, or sometimes we can find the slope using 2 points, which is something that might be a little bit new. So what the heck is the slope? The slope is describing to us how fast a graph increases or decreases, right? So if I do a quick little sketch off to the side of here, if I've got this red line and this blue line that are kind of describing, the situation that we're working on, you can see that that red line is kind of not as steep as the blue line is, right? The blue one is increasing faster than the red one, right? The same thing goes, if we're talking about things decreasing, right? I can have a red line that kind of looks like this and a blue line that's just like zoop, just like that. The blue one is decreasing much faster than the red line is, right? So that's what the slope is telling us. It's how fast a graph increases or decreases. So to find the slope from a graph, which might be the one that you've done in the past, right? If you're peeking ahead a little bit to the bottom of this where it says rise over run, maybe that sounds familiar. What we want to do first is we want to choose 2 points and find the vertical change between them, right? So when we're finding the vertical change, right, if it's a change that goes up, then that means that it's going to be a positive that we're going to grab for that. On the other hand, if the change in the verticality, right, the vertical change is going down, then it would be a negative number we'd grab for that. Right, so up, positive, down, negative, right? Makes sense. Same kind of idea for the horizontal change, right? That's what we need to find next. If we're going to the right, right, if you think about going towards the right on a number line, it's like you're making progress. You're going more in a positive direction. If you're going to the left, then you're going towards the negatives on a number line, so you're going in a negative direction. Okay. So after we find the vertical and horizontal change, what we do is we create a fraction out of those, right? And this is really the important part of this. We're going to create a fraction with the vertical change on top and the horizontal change on the bottom, right? And what we're doing is we can kind of abbreviate that to be the rise, right? If you're talking about going up or down, you're either rising or falling. And the run, right? You're going either left or right, right? So rise over run. Sometimes you can call it fall over crawl if you're going downwards, because it's like, if I'm rising, I'm not going down, right? But either way, it's all talking about the same thing. So to find the slope from a graph, right, let's take a look at this one. What I would really suggest is, we're going to look at this line in blue here. And what I want to do is I want to find 2 good points to find the slope between. So when you're trying to choose a good point, let's kind of talk about what makes that. So all throughout the graph, you've got these like grid lines here, right? Like all these grid lines that go all the way across that are just awkwardly outlined in red. What you want to do is you want to try and find points that cross those grid lines right where they meet, right? Because it's going to make it a lot easier. If I tried to choose, this point on that line, I don't really know how far over it is. Like it's negative 2 point something for the x and it's positive 2 point something for the y, but I have no idea what it actually is. So what we would instead do is choose something like this point right here, right? You can see, and actually I'll erase it one more time. You can see that it's right where those 2 grid lines cross. That would be an awesome point to use, right? Sometimes you might have to go a little bit further to look for another one, right? I don't really want to choose something like this because although it's on a line that goes up and down, it's not on a line that goes left and right. So that's not really a great point to use there. But if I go down to here, that's a point that we can use. No problem. So then what we do is we need to find the vertical change and the horizontal change between these 2 points. So for the vertical change, and actually for both of them, I guess, what I like to do is we read words from left to right. I read this problem as find the slope of these graphs, and I went in this direction, right? What I like to do is I like to think about the points the same way. So we're going to start with the point that's on the left, and we're going to kind of go over and go to the next point further to the right. So I'm going to start here. To get from that first point, I need to go up 1, 2, 3, 4, 5 spaces. So my vertical change is to go up 5, so it's a positive 5. Right? My horizontal change is to go over from there 1, 2. Right? And it's 2 in a positive direction, so let's say plus 2. Okay, so this was my vertical, and this was my horizontal. Right, so vertical goes on top for the rise, the horizontal goes on the bottom for the run. 5/2 is our slope, and that's it. Right? It's actually going to be better for us if we don't turn this into a decimal. Right? If we leave it as 5/2, I can know that that means up 5/2. If I turned that into, oh yeah, it's 2.5, then it's a little bit harder to really, tell what's going on if we needed to graph something with that. So leaving it as a fraction like that is just fine. Right? What I might have you do is try this one out, right? Find 2 good points where the grid lines cross. See if you can find the rise and the run on this one. So on this one, you actually have plenty of good points to choose, right? You could choose here, or here, or here, or here, even there, or maybe over there, or way back there, right? Any of those points would be great. What I'm going to tell you is that no matter which 2 you choose, you're actually going to find something that'll work out just the same. So let's say, for example, that I chose this point and this point. Right, if I'm thinking about my rise, I went up 1. Let's make this a little smaller. Right, I went up 1. And then I went over in a positive direction 1. Right, so my rise is 1, my run is 1, and 1 divided by 1 is just 1. Right? Let's say that I did things a little bit differently than that, though. Right? Let's say that I chose that point in blue and this other point in blue. Right? If I'm looking at my rise and run, this one time I'm going up 2. Oops. And I'm also going to go over 2 in a positive direction. Right? So again, my rise would be 2, my run would be 2, but 2 divided by 2 is also just 1. Right? These come out to be the same slope no matter what we choose. Right? Is it going to be easier if you choose the 2 that are real close together? Yeah, definitely. But does it still work if you choose other ones? Of course. So even if I chose something like this point way down there in the bottom left, and this point way up there in the top right, and if I go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, right, I'll get 6/6. 6 divided by 6 is still 1, right? So again, it doesn't matter as long as your 2 points are good, like points that are on those grid lines, and you count it out correctly, right? That's really all we're doing here. All right. We got a couple more. Again, it might be a good idea. Try pausing and see what you get, right? This one, if you're a little bit unsure about the negativity, right, follow along with what I'm going to do, and then I'll have you try the next one. So again, what I'm going to do is I'm going to choose 2 good points. I'm going to choose, why not that one and this one, right? If you tried this on your own, you chose either that point way over on the left or this point way over on the right. Those would also work just fine, right? So what we're going to do is, again, I'm reading from left to right. I'm going to go in this direction when I'm doing them. So I'm going to start with this point over here and travel to the one that's further down the line. So to go like vertically, right, the vertical change is that I'm actually going down 1, right? So remember that when we're going down, we actually grab that as a negative number. So we're going to go down 1 and over 1, 2, 3 in a positive direction to get to that second point. So my rise, quote unquote, is -1, and my run is 3. So -1/3 is my slope, and we're done, right? We don't need to do anything more than that. Okay. If you didn't try the last one on your own, try this one out, right? See what happens. So hopefully you gave that a shot. Let's see where we go. So you got a point there and another point here. Those are probably the best 2. You could also have chosen the one way up there in the corner, but that one's a little tricky because the arrow is kind of covering it. But either way, right, if I'm going from one point to the next, I'm going to go down 1, 2, 3, 4. So again, going down means I'm negative, so -4. I'm going over 1 in a positive direction. So my rise is -4, my run is +1. And then we can simplify this a little bit more, right? Simplifying is something that you should try and do, right? Not if it turns it into a decimal, right? But if it comes out nice and clean, we should get in the habit of simplifying. -4 divided by 1 is just -4, right? No big deal there. And then we're done. That's the slope. Bingo, bango, bongo. There are two special cases that we have to talk about, though. So say I had a graph like this one on number 3. Let's choose 2 points. Let's say that I had this point right smack dab in the center and this point a little further on down the line. So if I'm trying to figure out the vertical change between those 2 points, right, to get from one point to the other, right, I'm not going up or down at all. So my rise is just 0, right? That's kind of strange. And actually, because this one is kind of strange, let's think about it as rise over run, and then we'll write it out next to it. So the rise is 0, right? I didn't go up or down at all to get from this point over to that point. Right? As far as the run goes, right, let's say that we went over 1, 2, 3 spaces to the right. So my run is 3. So again, what I was just saying a minute ago about simplifying fractions when we were able, right? 0 divided by 3 is just 0. So when we have horizontal lines, like this one, horizontal lines have a slope of 0, right? That's because they're not increasing or decreasing, right? The slope is telling us how fast a graph increases or decreases. Well, if it's not increasing or decreasing at all, then that slope is 0, right? There's nothing going on there, right? It's just kind of continuing on as it is, right? So every horizontal line that's straight across, slope is 0. This other one is definitely a little weirder, right? So again, let's take 2 points here. Let's say we take this one here and that one right down there. So one thing, we've been talking about choosing the point that's further left to start at. I don't know which one's further left here. Let's say that we're going to start from this top one and we're going to go to the bottom one, right? So the rise, right, I'm going down 1, 2, 3, 4, right? So that is a rise of -4. So rise is -4, and then the run, if I'm thinking about how far left or right I need to go, I don't need to go left or right at all. So that's 0, kind of like with the last one where we didn't go up or down at all. And then we've got a problem. So in math, you cannot divide by 0. That's just one of those things that does not work, right? There's no way to do it. It's like saying, if I had a basket of 5 cookies and I wanted to split them evenly into 0 piles, that doesn't make sense, right? You'd be obliterating the cookies. They disappear from existence, which doesn't happen that way, right? So what happens here is that we can't actually simplify this, right? So we give it a special name. We call it undefined, right? And in our case, all that really means is that there is no slope, right? We cannot give a slope to this graph because, we don't know whether it's increasing or decreasing. It's kind of doing both at the same time, right? And it's going up and down at the same time, and our brains are going to start leaking out of our ears if we think too hard about it, right? So all it really is, we're just saying that this is undefined, which means that there's no actual slope we can use. All right. So then we get on to something that might be a little bit new, is the slope formula, right? And if you've been a little lackadaisical about writing things down up until this point, make sure you get this down, because the slope formula is something we are going to use quite a bit and you're going to see quite a lot. So, slope formula. When we're doing the slope formula, we use m to represent the slope, right? So if you want to give yourself little notes, m is the slope, so m is equal to, and what we're going to do is we're going to set up the skeleton for this. So what I want you to do is give yourself like a big fraction bar in the middle there, and then put some subtraction sign on the top and bottom, right? Just like that. So I'm going to keep referring to this as the skeleton for our slope formula, right? This is what it looks like before we plug anything into it, right? And this is what I want us to kind of get in the habit of starting off with when we're trying to calculate the slope using this formula. After that, on the top, we're going to have some different numbers, and bear with me, we'll kind of write it out and then we'll talk about what it means in a second. Up on the top, we're going to have y with a little 2 under it, so we'll call it y2 minus y1. And then on the bottom, we're going to have x2 minus x1. All right, so those little 1s and 2s are just kind of like labels. It's telling me which x and which y we're talking about. And the reason that we've got 2 different ones is because we're going to have 2 different points, right? So our 2 points, right, just like we had on the graphs, right, we had to have 2 points to find the slope. One of those points is going to be x1 and y1, and the other point is going to be x2 and y2. All right, so all we're going to do is we're going to have 2 points, like you might be able to see in number 4 right below. And we're going to start off, actually, let's just jump right into it. We're going to start off by labeling those points as x1, y1, and x2, y2. Right, so let's do that first. So when we're labeling these, right, literally just write, oh yeah, this is x1, and the y1 goes with it. All right, cool, those are labeled. Call this x2, and y2 goes with that. All right. So now that those points are labeled as such, what we're going to do, it might seem a little scary, but I promise it's simpler than it might seem, is we're just going to pop those numbers into this formula that we just wrote down. All right, so m is equal to, we're going to set up our skeleton, right, that big division with the subtraction on the top and the bottom. And then we're just going to plug those numbers in, right? Up top, it's y2, which is 15, minus y1, which was 20, right? Again, I'm just following the same pattern as it was up there in the formula, right? And that's why we labeled these, so it's a little bit easier to figure out where to put them. On the bottom, we're going to have x2, which is 6, minus x1, which is 14. All right? After that, it's just a matter of doing a little bit of math, right? So 15 minus 20 is going to give us -5. We're going to have 6 minus 14, which is -8. And if you want to use a calculator with any of these, that's perfectly fine, right? There's nothing wrong with it. So now that we have -5 divided by -8, right, there's a little something more we can do, right? If you have a negative divided by another negative, those two negatives will cancel each other out, right? So what we can have here instead is just regular old positive 5/8, right? And this is really what we want to get to, is having positive 5/8. That is the slope between those two lines, and then we're done, right? If it helps to think about it this way, right? If you think about what we're really doing in this slope formula, the y2 minus y1 up on the top, that's us finding the vertical change between those 2 points, right? It's saying, all right, how far apart are the y's, right? And the y tells us how far up or down we are. On the bottom, where we've got x2 minus x1, right? That's having us figure out the vertical change between the 2 points, right? It's how far left and right they are, right? And then we're basically doing that out with some math. All right, let's try another one out. So again, just like before, we're going to start by labeling these 2 points. We're going to call this one x1, and the y1 goes with it. And we've got x2 and y2. If you do happen to have 2 different colors to write with, like if you have a red pen and a blue pen, just like I'm doing, or if you have like a pencil and a black pen or something, I might suggest writing them in 2 different colors just to really make them stand out. All right, so after that, I've got them labeled. We got to plug them into this skeleton here, right? M equals, you got our big division, some subtraction on the top and bottom, and then it's y2 on the top minus y1. Right, and I'm plugging in every number exactly as it was, right? You can see that y2 is -12, so I plugged in the entire thing with that negative. On the bottom, we're going to have x2 minus x1, so 13 minus 15 down there. After that is just, again, doing some math. -12 minus 14 more is going to bring us further negative, so we're at negative 26. 13 minus 15 on the bottom brings us to negative 2. And then again, we can simplify this fraction, right? Because they're both negative, those will cancel out and our answer will be positive. So then 26 divided by 2 gives us regular old 13, right? And that is our slope here, right? So hopefully this doesn't seem like the absolute worst thing we've ever done, right? Let's take a look at a couple more. So on this one, I already did this, the liberty of copying down the slope formula again. So if you want to copy it down as it is, just to have it on this side of this page, it's right there for you. What I'm going to do is I'm just going to label these points again. x1, y1, and then x2, y2. All right, let's see where it goes. So again, set up my skeleton with some subtraction on the top and bottom. We're going to have y2, which is 9, minus y1, which is 9. On the bottom, we're going to have x2, which is 20, minus x1, which is negative 15, right? And this is the first time we're running into, why I like to set up the skeleton first, right? You can notice that on the bottom, we now have 20 minus negative 15. It's supposed to be that way, right? The negative in black is already built into the formula, and that negative with the red 15 is, part of that number that we plugged in. So what we do here is we turn that into one big old plus sign, just like that. Okay. Then we just do some math, right? 9 minus 9 is 0. 20 plus 15 is 35. And then 0 divided by 35 is just 0, right? So in this case, our slope is 0, right? What I could tell is that this is actually a horizontal line, right? It's not going up or down at all, right? So for this last one of this chunk of problems, what I'd like you to do is label your points, throw them into the skeleton, like get it all set up, and then see where you go, right? See if you can figure out what the slope's going to be. I will say that the final answer might be a little tricky. So if you need to follow along, try setting it up first and then follow along. Right? So hopefully you gave that a shot. Let's give it a go. I'm going to label these x1 and y1, x2 and y2. After that, I'm going to set up my skeleton. M equals big fraction with some subtraction. And then on the top, we got y2 minus y1. And then on the bottom, x2 minus x1. Ugh. So again, the reason that we set up the skeleton is for situations like this. On the top, we'll turn that into one big plus. Same thing on the bottom. All right. So 15 plus 7 is going to give us 22. Negative 18 plus 18 is going to bring us to 0. Oh no, we can't do that. So hopefully you might remember what it's called, right? When we have a case like this, we call it undefined, right? Which means that we cannot tell what the slope is, right? There isn't a slope that we can actually comprehend in our little human brains. Oh my gosh, right? It's just how it is. But that's it, right? We can't simplify that. So undefined is all we get, and then we're done. So what we're going to do is there are 2 examples left. What we're going to do is we're going to talk through number 8, and then I'm going to do out number 9 and just have it in the notes. If you wanted to check out the second example of this, it will be uploaded as part of the PDF in their class notes folder and all that. Let's talk about number 8. So to figure out if these points could lie on the same line, right, that on the same line piece means that their slopes are the same. All right, so what we're actually going to have to do is we're going to have to compare the slopes. So what I'm going to do 2 different problems. One of the problems, I'm going to figure out the slope between those 2 points that I just put the red over. In the second problem, I'm going to figure out the slope between those 2 points. And if those 2 different problems end up with the same slope, then that means that all of these can be on the same line. All right, so let's work on this first section first. All right, so actually, how about this? Let's do some different colors here so we can still use red and blue to help us organize. All right, so problem number 1. We've got x1, y1. We can call this one x2, y2, right? So what we're going to do, same thing as always, right? We're going to set up our skeleton, m equals big fraction with some subtraction. It's really hard to say if you try to say it out loud. Right? We're going to have y2 minus y1 on the top. We're going to have x2 minus x1 on the bottom. And again, skeleton really helping us figure out that those should be big plus signs there. 2 plus 2 is 4 on the top. 0 plus 6 is 6 on the bottom. And 4 over 6 is the same thing as 2 over 3. Right? And again, we want to try and get in the habit of simplifying those if we're able to. All right, and actually, so this was what we got from that first problem there. Okay, when we do out this second one, all right, let's use this nice purple color. What I would suggest doing, right, and you don't have to do this, but, just to make things a little bit easier on our brains, I like to erase the labels that I used for the first problem, because then I can call this one x1, y1, and this one x2, y2 for the next part of our problem, right? So let's kind of ignore that first point, right? Just kick it right off the screen. And what we're going to do is the same old deal, right? I'm going to give myself a little separator, and we're going to set up our skeleton. And just like before, we're going to have y2 minus y1 up on the top. And on the bottom, we're going to have x2 minus x1. Right? So what we're going to see is we're going to have 8 minus 2 is going to give us 6. 9 minus 0 is going to give us 9. And 6 divided by 9 is the same thing as 2 divided by 3, right? So then if I'm comparing those two slopes, right, you can see what I have circled in orange and what I have circled in purple. Those are the same slopes, right? Excuse me as I do a little bit of option editing there, right? So because they have the same slope, right, that means that we can say that they are on the same line. Right, so this one works out just fine. Right? And that's really all we're doing there, right? It's kind of a way to get more practice in and also be able to tell if 3 points are all on the same line together. Right? So again, I'm going to do out number 9 and have it as just part of the notes that I'm uploading to our notes folder. If you would like to check that out, like try it on your own and check and see if you were right, I strongly encourage it, but I'm not going to make you watch me do it. So that's going to do it for now. Be sure to check for any additional stuff on the Google Classroom assignment, and I'll see you next time. Peace.